Bismillahirrahmanirrahim. In the name of God, the most gracious, the most merciful. Welcome to A-Level Maths Year 1 live lesson. It's a series of lessons taking place Monday to Thursday, 9 p.m. to 9:30 p.m. British summertime. And my name is Mr. Ali. I'm the teacher. I've got about 8 years experience teaching maths at both GCSE and A-Level. And you're free to join me on YouTube every day, Monday to Thursday at 9 p.m. This lesson will start in a few moments. Aisha, wrong time to be in the bathroom. Okay, lesson is about to start. Bismillahirrahmanirrahim. In the name of God, the most gracious, the most merciful. Assalamu alaikum wa rahmatullah. Peace be with you and the blessings of God. A-Level Maths Year 1, when I was in this similar position, I wish somebody gave me some advice. So here's some advice to explain what you need to do to get an A at A-Level Maths. So what can I do, or how can I get an A? Just a little bit of advice. If you're aiming for higher than an A grade and an A star, then this advice is still applicable to you. First thing I'd recommend, it's not really a recommendation, you must do this if you want to get an A grade, is you must attend every single lesson. So if you're already in college, attend every single lesson of those college lessons. If you're not in college and you're doing this through home study, then attend every single of the lesson that I do via YouTube. Second thing is that you need to then do lots and lots of question practice. I mean lots and lots. So from the question book, from the textbook, I would answer every single question. And it's fine for you to get stuck. There's worked examples that you can go back to. There's answers in the back, but you must, if you're looking to get an A grade, work through every single question in that textbook. After that, even more question practice. You need to get yourself a CGP an exam practice question book, an exam style question book. It's broken up by topic, and you've got loads of really challenging questions in there, up to the kind of standard that you have in an exam. You'll get that for year 1 and year 2 of the A-Level. So work through every single question there. The difference here with the CGP book is that you're going to have to aim to do it twice. The first time you do that is working through the year and getting help from the answers, looking up questions from the revision book that accompanies it. The second time you do it will be closer to the exam, maybe at the end of the year when you've got an end of year exam, and you want to go through that book twice, and the second time you want to be getting less help from the answers at the back. And then the third thing you want to do, which I think most students know they have to do, but they just need to realize the amount of past papers you have to do. It's past papers, and I would say 10 years worth of past papers. And again, some of them you might want to do twice, but you want to work through the papers and of every single year for about 10 years worth. If you can do all of that, then I think you've got a really good chance, God willing, of getting an A grade. In terms of percentage, attending every single lesson, watching your teachers explain stuff to you, that's going to contribute to about 30% of your knowledge and skill in maths. The other 70%'s got to come from you practicing the questions. So the questions in the textbook, roughly speaking, another 20% will come from that. This is not marks, this is in terms of the time that you're going to have to put into this. And then from the CGP books, another 20%, roughly speaking, of your time. So if you think about it, just the question practice so far is going to have to be the 20% plus the 20%, 40%, that's more than the 30%. So all your lessons added up together, you're going to have to put in more time than all of those hours of lessons into question practice. And you haven't even got to the 10 years of papers yet. And that should add you up to another 30% of your time. So that's your time and effort really. It's going to take a lot of question practice. And while you're going through it, you've got to be asking questions. You're not a robot. You're not just going to be taking everything in and understanding it first time. At the end of a lesson, you've got to ask questions. When you're going through textbooks and finding stuff that you don't understand, look it up, Google it. But if you still don't get the answer, if you're still not 100% with it, you've got to ask somebody that knows and really quiz them, get them to explain it to you until you understand it well. Okay, today's topic is the very first topic, and we're looking at modeling. And this kind of modeling is really what drove some of the most amazing scientists of the past, who were great mathematicians as well, into developing in the science that they developed, the equations that they developed. So for example, Einstein, he looked at the universe around him and he said to himself that I want to write the equation that the universe is following. What's that equation that will tell me how the universe operates as it does? And what he wanted to do was really understand how God had made the universe to function in a certain way. And he was very successful. One of the key equations he wrote, E equals mc squared. Your physics teacher can tell you more about that. But that was an example of how he wanted to look at something that was real. The universe is real. And see if and try and write an equation that would tell him how that real thing is working. And then you've got other examples of equations that run the universe. The universe is run according to these equations. Another one is the gravitational force equation, where the gravitational force between two bodies is inversely proportional to the distance squared between them. And this equation, again, your physics teacher can tell you more about them, but this equation was used as a proof of how the universe must have been created by God, because an equation like this, where you've got the square of the distances between the two objects being inversely proportional to the gravitational force, that's not an equation that just comes out of thin air. That's something that's had a mind behind it, and it's been written in a certain way. And that's a proof that a famous scientist used to explain that the universe had to come from a creator, from God. So the kind of level you're going to be starting off at in A-level maths is much less than this. But the idea is to try and get an equation, some kind of equation that will help you predict or help you calculate a certain answer based on what you know. So for example, very, very simple equation or model might be used by an electricity company, say National Grid, the electricity company. If they want to predict the amount of electricity that's going to be used in a certain tomorrow or the day after or in a week or in a month, they'll use a model. So they'll say, well, we know the amount of electricity, the energy that people use is going to be dependent upon the electronic devices that they have, how long they're going to be at home, how long they have of daylight, and the time that they get up, and if it's not daylight they'll need to switch the lights on. The time that they get home will and again, if it's not daylight when they're getting home, then they're going to have to use the lights they're going to have to use electricity to switch on the lights. So these kind of variables they'll build into their equation, and then they'll end up with an equation that will then predict the amount of electricity used. Now that's not going to give a perfect answer. That's why it's called a model. It's a very simplified version of looking at the kind of question they're looking at. Another thing you could try and do yourself is if you want to make money, then you could try and predict share prices. Say if you want to predict the share price of Apple computers, the company Apple, again you could build an equation. You could write an equation to try and predict the share price based on how much money they're making at the end of the quarter or the year, the number of new products they've launched during the year or about to launch. So with these kind of variables in mind, you could then write an equation that will predict whether the share price will go up and by how much. These are all examples of models because they're not going to work it out exactly, but if you make certain simplifications, then the idea is that you get close. You get close to the real answer, and if you do get real close to the real answer, you could make a lot of money. So it's worth putting the effort in to try and understand how modeling works and what you can do to make your models better. But we're just going to start off with a really simple example. The workbook we're going to be going through this year is Edexcel, A-Level Year 1 Pure Mathematics. On other days, on other lessons, we'll look at statistics and mechanics as well, but we're just going to start with Pure Mathematics. Year 1 student book is the book. If you can get hold of this, it's available on Amazon. It's not too expensive. Then you'll be able to work through the questions as well after I explain the main parts of the topic. Of course, you don't have to wait for me. Feel free to read through the examples yourself. And your aim is really, it's a year 1 textbook. You want to really get through all of the chapters by around May, no later than May. If you can get through it earlier than that, then that's fantastic. So I would say, as a rough guide, you want to really get through half a chapter every week, so 1 chapter every 2 weeks. But today it's modeling, so let's take a look. Okay, starting off very, very simply, we're talking about a company, and the company predicts that its new product is going to sell 500 units in its first month. 500 units in its first month. And then after that, they're expecting that sales will increase by an average of 250 units per month. Write an equation to model the predicted sales of the product during the nth month on sale. So if we just think about this, we've got 500 in the first month, and then in the second month we've got 750, and in the third month we've got 1,000 units, so the number of units starts off at 500, but then it goes up by 250, so it now becomes 750 in month 2, and then in month 3 it becomes 1000, and then it goes on like that. So the idea of model here, you can just rewrite that in your mind as an equation. Write an equation that will give you the predicted sales in month M. So you could call that month X if you like. So how can we do that? Well, we know it's going to go up by 250, so we could say 250 times M, and we know it's starting off at 500, and that's the predicted sales. So we can say predicted sales is equal to 500 plus maybe 250 times M. The reason I'm saying maybe is because if we were starting at month 0, then this might work out. But remember, we don't count months as 0, we count them as 1. So if we put 1 into this equation, month number 1, then M equals 1, and the answer we're expecting is 500. So if I do 250 times 1, that's 250, plus the 500 makes 750. Now that's the answer for month number 2. It's not the answer for month number 1. So here I just need to change that M to bring it down by 1. So I'm just going to take away 1 from that. Because of the reason I explained, that we're not starting the month numbers from 0, otherwise that equation would have worked. So we're just going to go with plus the 500 can stay as 500, plus the 250 is fine, it's going up by 250. But instead of putting times in by M, we can put times by M minus 1. Now that should work. If I put the month number 1 into the equation, well, 1 take away 1 is 0, that's fantastic. Times that by 250 is 0, so I'm just left with 500. Just check, does that work for month number 3? I'm expecting an answer of 1000. So month number 3, that's your 3 would go here. 3 take away 1 is 2. 2 times 250 is 500, plus the 500, and that's exactly the number I wanted of 1000. So that's it. That's how you could write a very, very simple equation called a model to work out what the predicted sales might be. Why is it called a model? Because it's not going to be exact. It could be that things happen. It could be that the take-up of the product slows down after a couple of months, and so it's not going to keep going up by 250. Could be that word gets passed around by the first 500 people that buy it in the first month, and so as more and more people buy the product, more and more people pass the word around, then the product actually starts to accelerate. Instead of going up by 250, it goes up by more than that as the months continue. So that's why it's called a model, because it's not exactly how real life works, that things are just going to go up by straight 250. But for our purposes, it's a pretty good idea of what's going to happen to sales based on what we know. Okay, just a word of warning, there are going to be some topics within the year that are very easy, and I'm just going to ask that I concentrate the time in these lessons on the harder topics. So where we're talking about modeling, if you can, by the time we get to the next lesson, which is tomorrow, just read through the examples 2 and 3. Very, very easy to understand that if you're going to write an equation, then it's not going to work all the time. There are going to be some situations where it's not going to work, and for it to work, then you have to rely on certain things, such as in the example that we had before, that you're going to assume that you have to rely on sales going up by that exact amount, constant amount every month, and you have to assume that sales aren't going to slow down as more and more people get the product. As new products come out, you're still assuming that you're still going to be selling at 250 units per month. So these hidden assumptions, you've just got to be aware of them. It's not too hard, but just have a read through examples 2 and 3, and then next week we can go into something called we can go into the next topic, which is problem solving. Okay, just a few minutes left, so if there's any questions on what's been covered today, please feel free to ask. If there's anything you just want to ask about the course in general, feel free. But apart from that, look forward to seeing you. It's Monday to Thursday, 9 p.m. to 9:30 p.m. That's British summer time, that's London time, if you want to look it up on Google. And my name is Mr. Ali, and I'm your maths teacher. Okay, fantastic. Thanks for joining me. See you next time. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you, and the blessings.